Hi, this is Shifali here, and we are learning security in AWS. So, our today's topic is security at VPC level. Let's check into that. Cloud security at AWS is the highest priority. And that is the reason that AWS customers they get benefit from the data center and network architecture that is built to meet the requirements of the most security sensitive organizations. So security, it is defined as a shared responsibility model between AWS and you. So that says between the AWS and the customer. So let's find out what is the shared responsibility model. It is described as the security of the cloud and security in the cloud. So security of the cloud, where AWS is responsible for protecting the infrastructure that runs AWS services in the AWS cloud, right? Whereas the security in the cloud is a responsibility of the customer. And here we have the factors like maybe protecting your data or your company's requirements or the applicable laws and regulations. We have a nice diagram here to check what is exactly the shared responsibility model. So in this diagram, we have two parts. The bottom half is the responsibility for security of the cloud, and here AWS is responsible. So what this shows is the complete hardware or the AWS global infrastructure, which consists of regions, availability zones, and edge locations, right? So this is the place where the actual hardware resides of AWS data center, which can be the compute devices, storage devices, database, and the networking cables, all the hardware, right? That facilitates the AWS data center and run the AWS cloud services. Whereas the first half of the part shows the customer responsibility, and that is security in the cloud. So in this case, it determines that the uh, the data which is actually stored at AWS cloud, okay, a customer has a full control on it. Think of the EC2, which is categorized as the infrastructure as a service, right? So in this case, also the customer is required to perform all the necessary security configurations, maybe by configuring the security groups, right? Or by patching and updating the guest operating system, which is on the EC2. In the same way, we have the storage services like Amazon S3, Amazon DynamoDB, right? So AWS operates the infrastructure layer, the operating system, and the platform, whereas the customers, they access the endpoints to store and retrieve the data. So that is what differentiates between the security in the cloud and security of the cloud. Next, we have about the security, identity, and compliance on AWS. So here we have the list of all the features which AWS offers. Let's have a few examples on each of these points. Identity and access management. So this securely manage identities and access to the AWS services. It also centrally manage the workforce access to the multiple AWS accounts, and then it manages the fine-grained permissions and authorization within the custom applications. It also centrally manages your environment as you scale with the AWS resources. So example of the few services which AWS offers under the identity and access management is AWS IAM, AWS IAM Identity Center, Amazon Cognito. Then we have the AWS Resource Access Manager and AWS Organizations. The next one, we have the detection. So this automates AWS security checks and centralizes the security alerts. Also, it protects AWS accounts with intelligent threat protection, right? And then it automatically centralizes your security data just with a few clicks, and you can access, audit, and evaluate the configurations of your resources. Of course, you can track the user activities and API usage as well. And few of the services which actually help us in detection is like AWS Security Hub, Amazon Guard Duty, Amazon Inspector, AWS Config. Then we have the AWS Cloud Trail, and for monitoring, we have Amazon Cloud Watch. Another point here is network and application protection. This is one of the wonderful feature provided by AWS, and it actually centrally configure and manage firewall rules across your accounts. It deploy the network firewall security across your VPCs, and then it provide secure access to corporate applications without a VPN as well. Some of the services which can be named here is like AWS Firewall Manager, AWS Network Firewall, AWS Shield, and we have in that we have standard and the advanced shield, and then Amazon Route 53 Resolver. Next, we have data protection. Data protection, it discovers and protect your sensitive data at scale. It create and control the keys to encrypt or digitally sign your data, right? And then it's about the hardware security modules as well, which is nothing but the hardware which can be used to secure our data through encryption. Some of the examples or the services which offered by AWS under data protection is Amazon Macy, then AWS Key Management Service, that is AWS KMS. We have AWS Cloud HSM, then we have AWS Secret Manager. Compliance, so under compliance, it's like there is no cost and it is a self-service portal for on-demand access to the AWS compliance reports. And also it continuously audit your AWS usage to simplify the risk. Services which offer compliance under AWS is AWS Artifact and AWS Audit Manager. Okay, here is a nice diagram which shows us the multi-layer security offered by AWS. We are going to deep dive into these. So here we have, this is a kind of VPC which is given here, and we would have another deep detailed diagram for this. Now this VPC has a CIDR block range that is 10.0.0.0/16, which can consist of up to, in fact, more than 65,000 of IPs, right? If you consider this as a multi-AZ architecture, we have the instances which are actually protected by the security groups. And then we have the subnets, subnet 1 and subnet 2, with their own CIDR block range, which are not overlapping, and these are protected by the network echoes. And then finally, we have the routing tables. Apart from that, we can see here internet gateway and the virtual private gateway. So internet gateway is provided here to connect the public subnets with the internet that is outside the world. And then virtual private gateway is the one which is used when we want to connect our own networks to the AWS VPC. So let's check out what are security groups, what are network echoes in detail. And here we have our next slide that is about the security groups. So interesting to know that a security group, it controls the traffic that is allowed to reach and leave the resources that is associated with, right? So usually we create a security group and we associate it with the EC2 instance, and it controls the inbound and the outbound traffic for the instance. You can associate a security group with the resources inside the VPC for which it is created. Let me tell you, there is no additional charge for the security groups. And when you create a VPC, it comes with the default security group as well. Now here in this diagram, we have the inbound rules and outbound rules. And if you see here, this is the specific IP address, right, which is outside the VPC. And we are allowing the SSH from this particular remote server. That's why in the inbound rules, it says SSH over the TCP protocol over the port is 22, and then we are giving the source. Apart from that, we are also allowing the traffic to come in. And here the source is the particular security group, which is already defined. So all instances that are associated with this security group can communicate with the servers which are here, right? So inbound traffic says that the traffic which is allowed to be into the server, and then we have outbound rules as well. And here the outbound rule says that the traffic which can be allowed. So by default, the traffic which is allowed in is also allowed to be going out. That's why security groups are actually stateful. Okay. And the cross button which is showing here, it says that apart from this particular um, the remote server, any other traffic would not be allowed to go in. That is what the security group is saying. So I hope this is very clear to you. So rules of the security group, they control the inbound traffic and the outbound traffic, and you can add and remove the rules for the security group, right? If we think of some of the characteristics of the security group rules, so you can specify the allow rules, but not deny rules. Yeah. And then when you first create a security group, there is no inbound rules, and the no inbound rule, it means no inbound traffic is allowed until you add the inbound rules to it. Whereas when you first create the security group, it has an outbound rule and that allows all outbound traffic from the resource. So all outbound traffic is allowed from the resource when we first create a security group, but we can remove and change that rule as well. The components of security group rule, the components are here like the protocol, which like the protocol to be allowed. Okay. Then we have the port range here. Okay. So like example 22 is the range here. And then we have the source. So this is the source or the destination for the traffic to allow. And comments is another part. Let's check the next one, that is network echoes. Now, what are network echoes? So a network echoes or network access control list, it allows or denies the specific inbound or the outbound traffic at the subnet level. You can use the default network echoes via VPC, or you can create the customized one. Again, there is no additional charge to create your network echoes, or maybe for using the network echoes. Awesome. So if you see here, some of the basics of network echoes are that your VPC automatically comes with a modifiable default network echoes, the default one, and then by default it allows all inbound and outbound IPv4 traffic and IPv6 traffic as well. You can also create the customized network echoes and associate it with a subnet to allow or deny, right? So very important point is we can allow or deny. Here we have the rules, as you can see here. So you can add or remove these rules, and we have the rule number. So rules are evaluated starting with the lowest numbered rule, and that is given the highest priority as well. The lower the number, the highest is the priority. We have the type, that is a type of traffic, which might be allowed or denied. Then we have the protocol. You can specify any protocol that has a standard protocol number, port range, the listing port or the port range for the traffic. Then we have the source, the destination, okay, source and destination, and then allow or deny. So default network echoes, which comes with your VPC, okay, or when you create the subnets, they allow all the traffic to flow in and out of the subnets. That is the quality of the default network echoes. So I hope this all is good. If you see here, we have a star. Star says that if no rule number is matching, if no rule is matching, then this is the default rule which is need to be followed. Great. Here is a diagram created by me. Let's try to understand this. Now, this is showing a multi-AZ architecture. We have the region, okay, inside the AWS, we have a region. Inside the region, I have created one VPC with 10.0.0.0/16 CIDR block range. This is AZA and this is AZB, so it's a multi-AZ architecture. In both the AZs, I have one public subnet and the one private subnet, and they have their CIDR block range with the /24, which is not overlapping, right? Apart from that, we have internet gateway. So connectivity with the internet gateway for the public subnets, so that instances residing in the public subnet can communicate with the outside world. And we have the NAT gateway here, that is network address translation. And the purpose of NAT gateway is that when we have instances in the private subnet and then they really want to communicate with the outside world, then that is done through the NAT gateway. Because these instances in the private subnet, they don't have any public IP, and that's why through NAT gateway, there would be a possible communication with the outside world. Awesome. We have the routers here because we define the routing tables and we associate them with the subnet. So at the right side, oops, yeah. At the right side, we have here the route tables with the destination and the target. So this one is, if you see here for both the entries, the first entry is usually common, which says that inside this VPC and inside this cyber block range, the instances can communicate with each other, that is locally, communicating locally. Whereas the second entry shows here that if assume that this is the route table associated with the public subnet. So in this case, it shows that an instance in the public subnet can talk to the outside world through the internet gateway, right? In the same way, this is the route table for the private subnet, where of course the first entry is the same, that is local. They can communicate locally inside the network. And the second entry says that we have the instances in the private subnet, which again can talk with the outside world, but through the NAT gateway. I hope this gets more clear with the public subnets, private subnets, and the route tables, internet gateways, and also about our regions and the NAT gateways. Okay, awesome. So next we have our network and application protection on AWS, which is a little deep topic, and this is a complicated architecture diagram we can see here. So let's check on what this is saying. Okay, now this is showing that apart from the security groups and the network echoes, we can have the actually multiple layers of security which we can provide. So we have actually here, if you see the Shield Advanced, then we have an application firewall, CloudFront, which is outside the VPC, all these services. Okay, then we have the network firewalls. Then we have network echoes at the subnet level. And then we have the security groups at the instance level. Apart from that, we have the endpoints. So endpoints who can be the interface endpoints or the VPC endpoints. And in that case, that is a gateway endpoints. So through endpoints, we can access the services which are public, like S3 and DynamoDB, through the private IPs and then without leaving the AWS network. Let's check on a few of the services like AWS Shield. Now, AWS Shield, it is a managed distributed denial of service. It is also known as DDoS. So it's a managed DDoS protection service that safeguards applications running on AWS, right? It is in two different ways, AWS Shield Standard and the Advanced. So AWS Shield Standard, this comes at no additional cost, and it defends against the common, frequently occurring network and transport layer DDoS attacks. That is what we are understanding from the AWS Shield Standard. Apart from that, it works actually at the layer 3 and 4, where we can integrate this with the Amazon CloudFront as well. Another one is AWS Shield Advanced. Now, inside this AWS actually Shield, we have Advanced as well, which gives a higher level of protection, and it protects against attacks targeting your applications running on EC2, ELB, Amazon CloudFront, Amazon Route 53. But this comes with the cost, right? Let's check on the next one, that is AWS WAF here. So WAF is Web Application Firewall, and AWS WAF, it actually lets you create the rules to filter the web traffic based on the conditions that include IP addresses, HTTP headers, and body or custom URIs. Next one, we have the you can see here the CloudFront. So CloudFront is again another layer of security which is added in front of the VPC. Okay, network firewall. Okay, we have network firewalls. Then also we have the network access analyzer. Let's check out what is network access analyzer. If you see, it is here. Network access analyzer, it is a feature that identifies the unintended network access to your AWS resources. It helps you verify, like, it helps you in checking about verifying and improving your network security posture, right? If any kind of unintended network access relative to your security or compliance requirements is coming, then it helps us to improve that. And it also demonstrates the compliance. So it means whether your application and your complete implementation is meeting the compliance requirements or not as per the AWS. Okay, we have another one that is traffic monitoring. Now, here it is, traffic monitoring. It is an Amazon feature that you can use to copy the network traffic from an Elastic Network interface. Okay, the key concepts here would be the source, that is the network interface to monitor, then filter a set of rules that defines the traffic that is mirrored, target, the destination for the mirrored traffic, and the session, which establishes a relationship between the source and the filter and the target. That is what we have about the traffic monitoring. How it works, if we just go in little detail, so it copies the inbound and the outbound traffic from the network interfaces that are attached to your instances. Okay, so let's go on to the network firewall. Let's have a look onto that. Network firewall, here is the one. This is, it deploys, when we deploy network firewall, it secure the complete AWS, and then it can secure across your VPCs. It means with the multiple accounts as well. So with the AWS network firewall, you can define the firewall rules that provide the fine-grained control over the network traffic. It's a managed service, and then it deploy the essential network protections. So with just a few clicks, it scales automatically with the network traffic, so you don't have to worry about deploying and managing any infrastructure. So highly available, highly scalable. That is about the network firewall. With this, we are coming to the point of security best practices. So create the subnets in your VPC in multiple EZs. Use security groups to control traffic to EC2 instances in your subnets. Use network echoes to control the inbound and outbound traffic. Manage access to your AWS resources using IAM, Amazing Point. Then use VPC flow logs. So to monitor the IP traffic going to and coming from the subnet or the network interface. We have also checked network access analyzer to identify the unintended network access. And the last one is AWS network firewall to monitor and protect your VPC by filtering the inbound and the outbound traffic. That's about the security at the VPC level. Thank you so much. Bye-bye.